Okay, we are on air.
Are we live?
Yes, we are live.
Okay, thank you. Good morning, good afternoon, everyone, or whatever time zone you are in. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam
Waalaikumsalam warahmatullahi
warahmatullahi
wabarakatuh.
wabarakatuh.
Okay, hi. We have back again to our Sunday podcast with me, Rendia, and to our friends here, Adil and Andra. So today we have Andra as the main speaker, the guest here. I am the host. I'm going to be leading this discussion forward. All right. So Andra, what are you going to show us today?
Uh, I wanna talk about electrochemistry.
Electric
Electrochemistry,
chemistry.
yes. Have you ever heard it before, guys?
I think I
I
have.
I
Oh,
think
that's
I
good.
have chemistry in my high school, I guess.
Yeah, third year, right? Third year.
Yeah, third year, I guess. Yeah.
Yeah, it's interesting.
So,
We will discuss about it.
all right, good.
Uh,
Show me
okay.
what is so
Hold on.
interesting about electrochemistry.
Hold on. I'm gonna share my screen first. Have you have you seen it?
Hold on.
It is loading
Okay.
right now.
Ooh, nice. Yeah, I can. Yeah, can see
Uh,
it.
Oh yeah. Please,
it's so
Andra.
already.
Click hide button in.
Yeah,
Yeah.
the Meet Google section, like they are stop sharing and
Yeah, I
hide. Just hide it.
already click it. Yeah,
Okay,
yeah, I
nice.
already
Good.
click it already.
Wow. Okay. Nice. Beautiful presentation, if I may say.
Okay.
Continue.
All right, hello guys. This is Sandra, and today we're gonna talk about electrochemistry as our topic. So first, what do you think about electrochemistry, guys? So you see that there is words electro meaning electricity, and there is a word chemistry which is chemistry. And if we combine it, then electrochemistry is learning
Chemist.
about chemical difference produced by the electricity currents as well as the electricity current information by the chemical reactions. Hold on, guys. I think I'm gonna first open my pen tab to be able to present you better.
Oh, you want to use it? Okay.
Yeah.
All right. So
Do you mind it?
Yeah, I'll be fine, but I
Okay.
hope it doesn't take a long time.
Yeah.
Uh, so while we waiting, can you tell us like
Oh, okay. Yeah. So in electrochemistry, you see that we usually fast our own devices such as phones or computer as well as laptop.
hmm?
So from that, you see, battery is an example of electrochemistry.
Battery, yes.
Yes.
Because they store energy to by chemical reaction, right?
The
And
chemical
then
reactions. And now, uh, it is added by these current situations that everyone would like to have EV
oh
or
sure,
electric vehicle. Yes, that
electric
will
vehicle.
require a lot of battery sources. But then, I mean, the demand will be so good to meet.
Mm-hmm.
Okay, hold on.
Nice.
Yeah, I mean, like the electrochemistry itself, learning about the relation between.
So what you're saying is this electrochemistry is important because in the future, or at least in the near future, we going to have a lot application in there. For example, like battery and basically EV, basically, which going to have a lot in common in the near future, something like that.
Yes, of course.
All right.
So that's why we are now learning about electrochemistry to be able to produce some battery, right?
All
And
right.
then you see that electrochemicals process require several ways. Okay, several ways to conduct electricity into reaction system.
Mm.
And this electrochemical process requires at least two components, and it's gonna be cell first, and then electrodes.
Electrode. Oh.
Electrodes, okay.
What is cell and electrodes? That's a good.
Yeah, this is our
That's
question right now. Okay, so first we learn about the cell. Okay, cell is a medium.
medium.
Medium, the place where the the process of electrochemistry happens. Okay, and it's we can say that it is an environment to do the electricity conduct.
Environment.
And what is electrode? Electrode is the conductor that will help to conduct electricity currents to to happen. It is divided by two types. There is
Mhm.
anode and cathode.
Okay, so what you saying is cell is sometime some a medium or perhaps a closed system
Yes,
where
the
yeah
ecosystem. Yes,
where the
you are true.
electrochemistry happens, right? For
Yes,
example, like in battery,
in that way. Yes,
in there you can use your basically they are chemistry and basically turn into electricity in this in there.
yeah, of course.
Right.
Yeah,
Okay,
you are
okay.
true.
How about electrode?
How about electrode?
Electrode is a conductor.
You
Let
mean
me.
like some kind of material to execute electrochemistry?
Yeah, it is some material to execute the electricity. For example, like this. The electrolysis of sodium chloride melt. Okay, you see
Hmm.
here.
Yeah.
Right,
We have we have a box. We have a box here.
right.
We can say it cell.
So,
We
Oh,
can
that's
say
a
the cell.
cell.
Okay.
all right.
Okay, I will try to erase this first. And then when it comes to electrode, oh, why is it so hard? Okay, and then when it comes to electrodes, we can see this and this. You see, it is anode and it is a cathode. Okay, so anode cathode is really that anode and cathode are conductors that will help the electrons to flow the wire.
Oh, so the electrode is the part of the cell that will conduct the electricity by from the anode, which is the negative part, to the cathode, the positive part. Is that true?
Yes, of course. And then
Uh,
what you would concern is that
and then react.
anode and cathode is not really, when you say cathode, it's not really uh, you know
Positive and negative.
positively charged
Oh, I see.
or negative charged. It depends on the type of the cell.
Oh, I see. So basically, electrode is just two part that conduct electricity, and
Yes,
they react to the chemical in the cell. Is that true?
yes, that's true.
Okay.
And you see, Ren, that for example, like when it comes to voltaic cell,
Mhm.
the anode is negatively charged.
Okay,
But
hold on. What is voltaic and electrolytic cell?
all
Can
right,
you?
so I will explain it. Galvanic cell or voltaic cell. We
Mhm.
usually say it voltaic
Oh, you use the
only
voltaic.
to ease the conversations. Okay,
Mhm.
the voltaic cell is something that converts chemical energy into electrical energy.
All right.
For example, battery when you use, right,
Yeah, we use
you
battery
you
from
use
chemical.
battery to, for example, turn on the lamp. Okay,
Mm.
so the electricity comes from the chemical compound from the battery into the lamp in electricity. So yeah, that's why we say it as spontaneous reactions instead. Spontaneous.
Spontaneous.
Yes,
So it immediately happens, right?
immediately
Okay.
happen. Okay, and
Would you consider the whole light bulb and its wiring part of the cell, or
sorry.
like this is a battery connected to light bulb, right?
Yes.
There is the whole system is considered as a cell, or not?
Yeah, we can say it's cell. I think. Yeah, we
All
can.
right.
Yeah.
Okay.
And
Uh,
okay, so the point is that we should differentiate between voltaic and electrolysis.
electronic cell.
Yes,
Okay. Good.
and the
Okay.
electrolysis is the reverse of the voltaic. You see, it converts electrical energy into chemical energy. So,
Hmm.
for example, like you you charge you recharge your own battery at your phones. Okay, so you see the electricity comes to your phones and the electricity is stored to your battery. Okay, so we can say that the electricity becomes the
Chemical.
chemicals. Yes, become chemicals energy.
Oh, I see.
And you see that the both anode are different here. The voltaic anode is negatively charged and the uh, electrolytic anode is positively charged, as well as the cathode.
Hmm. I
Cathode
see.
in voltaic is positive, but cathode in electrolytic cell is negative.
Also.
However, you
Mhm.
see, it is non-spontaneous cell reactions, meaning it's not gonna make up some electrical conduct
Hmm.
or the energy potential or voltage. I think
I see.
this is
Oh,
the detailed differentiations between
voltage.
voltaic and electrolytic cells. As you can see, for the electron flow, you see voltaic electrons flows from anode to cathode. In addition, oh sorry, on the other hand, the electrons in electrolytic cell flows from cathode to anode.
Yeah, you know what? I think we have learned it before when
Yeah, in high school, yeah.
when
I think
our
we can barely
yeah.
remember the
You
surface
know
of.
that I think it is the hardest chemical you know like BAP in back in my high school, you know,
Chapter in high
because
school.
yeah,
I
for me
see.
at least it is like really chemical stuff, really hard. I don't really understand it when I was in my school, but I understand it through uh crime school.
What do you
What?
mean? What do you mean claim school?
uh
Crime school.
you know,
Yes.
like Nurul Fikri and
Oh, NF. Yeah, I already, I've ever been NF too.
oh, you are
Okay.
NF. Oh, how about you?
Yeah.
Randia, wait. Randia
No,
must be in 10.
I used to be in Bintang Pelajar, to be
Oh,
honest.
bintang
BP,
pelajar.
do you know BP?
Oh, I know, of course. Okay, so why
Oh,
did you stop your presentation?
yeah. You start your
That's
presentation.
one thing I don't really understand.
All
Just
right.
wanna comment something.
All right. While we waiting, I think we deserve some.
Yeah, you see, I think there are examples of both. You see, galvanic or voltaic cell
Hmm.
has examples for batteries, and
All
then
right.
electrolytic instead has an example of purifications and electroplating. All right,
Hmm.
so you see, I want to talk about electrolysis first. Electrolysis works to separate a chemical compound to be broken away as it would not like to happen by its own.
Okay, hold on. So basically, what you mean is
What I
electrolysis
mean like this. What I
is.
mean like this. Like you see, there is sodium chloride
Hmm,
melt, or we can say the table salt melt.
molten.
Yeah, consisting of NaNCl. All right, in the same cell. You see, uh, so your mission is to separate NaCl to be uh, their own, but I mean respectively Na plus NCl. So by you give some electricity from anode. I
Hmm.
mean this is battery, and when battery is installed, the Cl will come to anode, as the Cl wants to have positive charges. So it leaves the NaCl, and NaCl 2 wants, Na plus wants to get cathode to have negatively charged, and it becomes like this. 2Cl from NaCl would be Cl2
Hmm.
2e, like this. The electrons from the Cl flows from this to cathode, and the electron from the anode will be received by Na plus. So yeah, basically they are separated, and
Oh.
it is called of half reactions.
Half
Hmm.
reaction.
Half reactions. Have you ever heard it before? Half
I
reactions.
think I forgot. I don't know.
I forgot too, I guess. But I can see what happens here.
So there should
So,
be full reaction.
Yeah, full reaction is like this. Uh, two of two of these are half
Oh
reactions,
yeah, yeah. You know
oh,
this electron.
and
yeah,
Randy.
yeah.
You know this
No,
and
equation.
nee, look, okay. So far that I got from this system is basically we use battery to conduct electricity from anode to cathode. Basically, since anode is going to be remove the electron. Sorry, battery going to remove electron to anode. Basically, anode is going to be positive, right? Positively charged, and the cathode, which has a lot of electron in there, is going to be negatively charged. Basically, what happened is this molten NaCl or salt is going to break down into Cl negative, which is attracted to anode, and natrium, positively charged natrium, is going to be attracted to cathode. Basically, is that true, Andra?
yes, yes, you are true.
So given that reaction, it's going to be creating this half reaction, which Andra shows something like and both of them it comes to this cell reaction. Hmm. I
Yeah,
think
it,
it's
it,
new.
it is very true. And Ren, please guess what does this reaction aim to?
Oh, what this aim to isn't just to separate
Think it is to separate uh, salt
salt into,
to.
or
Yeah,
maybe you want to get chlorine itself, like
yeah.
yeah.
The both answers are really true. You see,
Oh,
our
yeah, to separate
missions
basically
actually to have this sodium.
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 Oh, it is.
Sodium. In English, natrium is called sodium,
Hmm.
and sodium itself is a kind of metal that would be beneficial for industries, and yeah, that's why we can
Separate.
extract it from the salt. And then from bonus that we have, we can get chlorine too. Chlorine could kill
Bacteria.
bacteria.
Oh,
Yeah,
Yes,
that's why
bacteria.
they use on
bacteria. Yeah.
pool. I see.
It is
So
some acid stuff, right?
some acid.
Yeah, yeah. Acid.
Uh,
Fluorine
well,
is
I don't
acid.
think. Sorry. I don't really know about it. But what I know, it
Oh,
is to
Randy, I can
kill.
be sure.
No, no, because because in high school we learn about
HCl,
natrium
HCl.
is, yeah, HCl,
Oh,
yeah,
HCl. Yeah.
HCl, like, yeah.
Yeah, when we
The
talk about HCl, I
yeah,
mean,
natrium
yeah,
is
it is acid.
alkaline and
Yes, it is acid.
Oh
acid.
yeah, yeah, that's
Yeah.
right. But chlorine, only chlorine, we don't know. You,
Yeah, but if chlorine only chlorine,
It is acid,
I
right?
still do not know about the pH level or the acidity.
oh yeah, yeah, yeah.
This
All
is
right.
only my opinion, but I don't think. I mean, I think the way that I learn is alkaline plus acid and into salt, something like that. So I thought Cl2
Uh,
is acidic.
okay,
But
so now we are
okay,
talking
hold on.
about electrode first.
Mhm.
Electrode is the surface where a half oxidation or reduction happens.
The surface, all right.
Yeah, you see the cathode, the electrode where the reduction happens. Okay. So in school, Rendia, do you know about karet?
Uh,
Rubber.
Rubber.
Karet
Oh
is
no
not
no, cathode reduction, right?
cathode reduction, and
Eh,
uh, yeah, cathode reduction, and anode is oxidations.
There's a local short like a local shortcut teaching way like
Yeah,
our
local
teacher.
shortcut. Yeah, and yeah, this karet or cathode reductions and anode oxidation are fixed, meaning it 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 is not affected by it is whether it is electrolysis or voltaic.
All right.
We jump to this voltaic. Okay, we already learned about this electrolysis, and now we learn about voltaic. Okay, so uh, the voltaic itself is to I mean is divided first is divided by two cell ren or Adil.
Oh,
You
okay.
see, this is the first cell, and this is the second cell.
Okay, we cannot just mix them both because they
Yeah,
are
it is different with the electrolysis, which is just one cell.
Oh,
right. All right.
so we combine. I mean, it is all in one wadah. In
Ah, yeah,
Yeah.
one.
wadah
Yeah.
What is
in
wadah?
one medium.
Medium.
Medium. However, we separate two mediums in here. To yeah, yeah, two glasses in here. Oh yeah, yeah. Okay, okay, okay.
Okay, so you see that this liquid is actually Zn plus eh
Zinc plus.
Z.
Zn2 plus, yes.
Oh, so the first medium is has a positive charge and the second medium is have highly negative charge. So basically they want to send electron to from to first medium to second medium. Is that true? Is something like that?
Yeah, you are true. I mean,
Okay.
what I know is from these reactions, Cu2 plus in the right side
Hmm.
pulls electrons more powerful than Seng in
Zinc,
the
zinc.
left side.
Zinc. Also,
Yes.
the zinc gives electron to the what is Q? What is Q?
Yeah.
Cu.
Tembaga.
So basically, yes, you are true. The
Wait.
Cu2
Two.
plus pulls the electron from the zinc in this cell to
Oh,
this.
it's so. Oh, it's copper. Oh, it's
Oh yeah,
copper.
Yeah,
copper. Tembaga.
Okay,
Copper.
all right.
copper, and it is
Yeah.
like this.
Cooper, man. It is cuprum. Oh, no,
Copper.
I don't know.
Cuprum.
How?
The Latin word is cuprum, but in English we say it copper actually.
Copper.
Oh
Like a
yeah, yeah,
sodium and natrium. All right.
Mm.
Got it. Got it.
yeah.
So
So,
you
Copper.
see like this. When Zn2 plus gives electron to
2 plus.
the cuprum, then
Mm-hmm.
this
Copper.
natural Zn will turn Zn2 plus, Zn2 plus.
So at first they are zinc, and
Zinc metal,
after
yes,
after that they we have zinc which have a positive charge 2 plus.
yes, you are true.
All right,
And
got it.
the cuprum itself from the liquid will be stuck with the cathode and becomes neutral. Cu2 plus has a strong pull for electrons, so it becomes uh, cuprum neutral when they receive the electrons from zinc. All right, and
All
it
right.
becomes like this. So when it is saturated, the C enclosed will be solean and cuprum will be fat.
Okay, so hold on. So the zinc and Q are one element, right? But the water in not the water like the
Liquid.
liquid part is zinc SO4, which is
Yes, the liquid in the right side is full of cuprum sulfate, and the liquid in the left is full of zinc sulfate, and it functions to support the reactions in order to result
mm,
in the voltage, electrons flowing through the wire. But when we plug out the wire, so the electrons will not come to the cuprum side.
also
But when
okay.
we install wire, then the electron will flow. So
Mm,
it'll move the voltmeter instead.
I
So
see
it zap us if we touch the wire.
Yeah, it'll shock you, I think.
a
It'll shock
little
you.
bit.
All
Okay,
right.
I got a question. What is the purpose of salt bridge?
It is to neutralize.
Salvage.
No, 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 Andra, I forgot.
Go
It
ahead.
it is actually to balance the excessive anion. It is actually to aim the excessive both cation
Mm-hmm.
and anion from both sides. And then in addition, it is to prevent yeah, it is to continue the reaction will under control. This is what I know.
All right. Oh,
From the topic, I don't know. I don't really know about salt bridge yet, so I will learn about it later. I will
re-
find.
all
Yeah.
right. Good. Okay.
So maybe it is to prevent the saturated between both of them. In in nutshell, yes. In nutshell,
Mm,
it is to prevent the excessive ions between of them. So the continuity will happen constantly.
I see. I see. Okay.
All right. So what do electrochemicals for? It is for battery cell. Sorry, it is actually for battery cell. It can be used for battery cell. It can be used for metallic extractions. Like I already said, to extract metal, to extract sodium metal from salt.
Mm, from like from natrium from okay, I got it. Mm.
And then it can be used for metal purifications. Okay, for example, like once you wanna purify the ferrum like, or iron, yeah, you can use the electrochemical, and it can be fuel cells. It can be fuels, and lastly, electrochemical could do some electroplating.
Electroplating.
Yeah, electroplating.
I see.
Oh,
So
electroplating.
from what I know from the lab occurrence, okay, so let's say there is a stick of uh, the possible steel that will be corrosive or stained. Okay, so by electroplating,
Remove.
uh, we coat the surface by the chemicals of the inert chemicals. Okay, for example, like nickel or I forgot about it, or cobalt. Maybe I forgot. But the aim is to prevent the iron to be corrosive or stained. So it will be stainless steel.
I see.
Yeah.
So
So
Stainless
that
steel. So it
to
is
make a plating. Mm.
yeah, it prevents rust
hmm?
in
Yeah,
the
it
metal.
prevent rust. Yeah, on your spoon, on your fork, something
Yeah,
like
Hmm.
that.
yeah.
Yes.
Right.
Okay. Now we are talking about types of battery. We see that battery actually has two types. The first, of course, the primary battery. Okay, so battery that could not be recharged.
See, that's
Okay,
usual battery, and the second one
the
is
second one is rechargeable battery. Okay, so the battery
secondary.
that can be recharged as it is used. For the
Like
primary battery, it is only used for once. Okay,
one by
after that, I mean the chemical is in equilibrium state, meaning it kind of saturated. Then yeah, we should dispose it instead. For the secondary battery, it will work like your battery's phone. Okay, eh,
yeah,
phone
like
battery. Yes, it could be rechargeable until their lifetime, meaning a lifetime of battery is the lifespan that battery will survive, or until it meets the lifespan, the battery's efficiency will drop. Then like what I have in my life charge battery, you see, from 100%, it could be 50% or 20% in just for seconds,
For
because of the
seconds.
huh?
4 seconds.
Yes, I mean, I don't know about my laptop battery. It will drop from 100% to 5% only, or 10% in several seconds. But sometimes it could survive until an hour. So it is an anomaly about my battery's memory.
good damn. All right, okay.
Yes,
Yeah. So,
since
um,
it's lithium, I mean lithium ion battery.
hmm,
Okay, you see
go
this
on.
is battery compositions. Okay, you see first.
All right.
Where
It
is
is
the
first primary or secondary?
Uh, it is probably secondary. Yeah,
Oh,
secondary.
secondary. All right.
Yes,
so this is rechargeable?
yeah, it's rechargeable. And you see the inside is cathode like this,
Mm-hmm.
meaning it flows the electrons from here, since it's I mean negative. Yes.
Oh, wait, hold on. So the cathode is connected to the bottom, right? From what I'm
The
seeing here.
cathode is connected to bottom. Yes.
Yes. So and then the anode. Where's the anode? I can't see the anode. Oh, there you go. The zinc alloy can. So
The anode
anode
is
is
here, man.
yeah in on the side, right? Anode is on the side. It's connected to the above the the part in the above, right, in the one piece metal cover, which have some kind of nipple to it.
What? Uh,
The above the one piece metal cover, the above the plus the positive one.
Positive one. Okay.
Yeah, the
Oh, you
above.
mean like this?
Yeah, that one is the one who has a nipple.
Oh, here nipple.
Yeah. It's connected to anode. Is that yeah something like that? Is it something
Uh,
like that?
well, I think
How does it work? I don't
I think
understand.
that yeah, it will work like maybe, you see, this is the kind of electrodes, okay, of the
Hmm.
ions, and then the bottom is the negatively charged
Yes.
electrodes. Okay, so I mean it is supposed to be plus, right, for carbon electrode.
All right. Okay.
Okay,
Uh,
and now from the bottom we can uh,
connected to the
we
top.
can yeah, install wire until the top from the bottom to
Hmm.
flow the uh,
Electricity.
yeah, continuously, um, the potential difference.
All
Yeah.
right. All
So
right. I have a question, Andra. Where is
okay.
the South Bridge here?
Maybe carboelectrode is salt. No, I don't know. Yeah, where is salt bridge? There are no salt bridge here.
Uh, there is no, well, hold on. I mean,
Okay,
what?
but this is a voltaic cell, not a electrolysis cell. Since this is from chemical to electricity, not electricity to chemical.
Yeah, this is actually voltaic. I mean, because
Yeah, they don't need salt bridge for it if they are voltaic, like the molten salt experiment.
voltaic
No,
needs
no,
salt bridge.
this one
Oh yes.
for
Oh yeah.
type.
All right. Okay. Hold on. Okay. Hold on. Where is the salt bridge in there? Okay. I'm.
Uh,
So does it mean
well,
it wasn't
our
necessary?
well, maybe the salt bridge is carbon electrode, maybe.
Oh, carbon
I'm
electrode.
not sure about it. Yes,
Oh, I
I
see.
will run it later.
Oh,
Because when it comes to battery, it's more complicated, man.
Oh
okay.
yeah, it
Hold
it.
on. Hold on. So basically, cathode has a lot of electron in there, right?
Cathode.
Has a lot of electron. The cathode mixture has a lot of electron in there. Basically, what happens is if we connect the metal bottom cover to the to the top cover, basically it will flow electricity, the electron, into the anode, right?
Yes, yes.
Yeah. I get it. I get it. Like I understand. So this is a voltaic cell, and I think I don't know. Like carbon electrode is just a metal that conduct electricity. Maybe I think yeah. I think the carbon electrode is the kind of the salt bridge. Like although it's not a salt, but it's kind of a bridge to the to uh just to make sure the whole system is connected to make
Yeah,
a closed
make sure the
system.
whole system is connected. Of course,
Mm.
yes. And the liquid is here. I mean, the mixture of it is such a toxic compound chemical.
Mm. I
So
see.
it should be wrapped by the rigid can like this, because it is toxic when it is exposed to your own skin. I don't know. Maybe it will affect your health, since al- almost the battery's composition is toxic. So make sure, guys, you will avoid it when it leak.
Okay, including our laptop's battery.
Yeah,
That's
yeah,
good.
you are
Yeah.
true. You are true. That's why the government, I think, really suggests us to not throw the battery in common
Oh,
trash
that's
bin.
it. Mm.
Yeah, it should be stored in the battery trash bin, which is the dangerous compound.
I see. I see. It kind of interests me though. So the composition of battery intrigues me because I never thought like it
Hmm.
could be like the cathode like in the center and not in the center itself but the almost center and the anode is kind of wrap around the cathode something like that. Of course they are separated by a separator like insulator, right? And then
It's
they
butter.
are yeah.
Yeah, because
So
when you keep connected between the cathode and anode continuously, so the electrons will move
flow
electrically.
yeah.
Yes, and the potential energy will drop or empty instead.
Mm.
That's why
Uh,
it is important to give barrier between anode and cathodes instead, to prevent the electrons empty.
okay, all right. So, is that all that you want to show us, or
No, I will show you about later topic.
I see. Oh, you want to continue this topic in the later podcast?
I mean,
Oh,
for
right now, right now. All right, good.
Randia is confused.
I am confused right now. Oh, since you are stopping the presentation.
yeah,
Okay, good.
you see, uh, there are two ways happening in battery. First, when it
Secondary
yeah,
battery.
the first, when electricity energy converts to chemical energy, it is called electrolysis. And the second scheme, when chemical energy converts to electric energy, it is called as fault type.
I see. This is a secondary battery, right? The one who's rechargeable.
Oh
Yeah,
yeah.
this is kind of
Yeah.
secondary battery that is rechargeable, I think.
Okay. Continue, please.
Uh, First, the thing is that you see that yeah, I mean the cathode is the top and the anode is the lower, man,
I
in the lower.
see. Okay, go on. Sorry. This is yeah. Okay, go on.
Yeah,
Go on. Hmm.
all right. And then this is the table of battery types. You can see that from the range of alkaline, zinc carbon, lithium or lithium thionil, and zinc air.
All
You
right.
see
All right.
about the
Okay.
nominal voltage and the approximate energy density, uh, millijoule per kilogram.
All right.
I
Where
see.
where 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 do we use nickel here?
Yeah, I can't find nickel here.
Uh,
The news is like people use. There are
Nickel.
news that Indonesia has a lot of nickel storage there,
Yeah, I mean
and
it is
they will be
Indonesia is
used.
the largest. Oh, yeah,
The
nickel.
largest,
Nickel.
like yeah,
from
and where is the
nickel,
use?
you see from this
Oh
uh,
my God. What is this?
uh,
Is this your uh is this your exam
Oh no, this is your.
this is my paper actually.
paper
Yes,
for bachelor thesis
no for Randy.
or India?
Yes, because
Yeah.
Randia is wondering about the topic, so yeah, I'll give this paper for Randia. And
Oh,
I already
So
created.
this is the oh this is my request. Oh god damn. Alright, good enough. I request Andra about battery and he also this is
so this is a
This is for
literature
the nickel.
study.
I mean, for NCD, any
I
nickel
see.
cadmium battery.
All
Nice, nice,
right.
nice.
Alright, so a nickel cadmium battery is infamously used in cutting tools or camera and etc. The benefits of this battery are light, yeah. So it is light to bring, and then the drawbacks are, yeah, of course, it is to produce cadmium toxic compound.
Okay, that is the cons, the drawbacks. Okay. Nice, nice. Oh my god, you really did it.
Yeah, and it is like the previous battery that we
Yeah, we talked
talk.
about.
Yes, it consists of the cathode on the top and anode in lower.
Hmm.
So the positive electrodes should be an EOH, all right,
Mm-hmm.
but the
And the
negative
like
is
negative.
cadmium. Yes.
Cadmium.
So
Got it.
nickel here is the positive electrode.
So it receive electron from the nickel. Sorry, from the cadmium. I see.
From the cadmium, of course, man.
Yeah, yeah, yeah.
All right,
Okay,
so
get back into the. Okay, this is the
right.
battery.
So this
Dry
dry
cell.
cell, yes. You see, the dry cell is sort of battery that has been widely used since decades ago. A battery cell has the capacity of 1.5 volts. Okay.
Mm-hmm.
So the benefits of this kind of battery is inexpensive. So it is not costly or cheap. In other words, secured, available in various sizes. Meanwhile, the drawback is it will form ammonium gas that causes the voltage drop in the high electric current. So you see, when your battery is sick, I mean,
He's sick.
it will be kembung. What kembung?
I see. So
Your battery is will
bloated
gonna be fat
like a
first. Yeah, before it explodes.
so a bloated like yeah, yeah. So
Yeah. So
getting the
the the minutes before it explodes, it will be fat in
Fat.
size. Meaning, yeah, there is
is
huge amount of gas inside, then it will be blown up.
okay. Okay, got it. It because of ammonium gas, which
Yes, of course.
yeah, I see.
So you see the difference between wet cell and dry cell. Okay,
Is
maybe wet
this
cell is like you can find in IQ water, right? IQ.
oh
Yeah,
I'll call it like in the car battery, right?
car battery. Yes, for battery.
Yeah.
But sometimes in your common battery is also and you see dry
They
cell
are.
is wrapped by only metal.
So IBC battery and I don't know, I forgot. It is a dry cell.
ABC.
ABC. Or like Energizer or
Energizer, or I don't know.
the
So
type of battery like
Well, I think it's
A.
an wet cell, right? Wet cell is it?
it is still a wet cell.
Because I think that it contains liquid inside, but I'm not sure about it too. When you find it, when or you cast it through the battery, if
So
you cannot find the liquid, then yeah, it's gonna be dry cell.
so this is a wet cell? What, sorry, what is it?
Yeah, if there is liquid, then it will be wet cell. But if you cannot find the liquid at all, so it's gonna be dry cell.
Wait, this is carbon zinc battery. Oh
Um,
yeah, okay, maybe yeah, that's true. I guess
So
it,
so it is a wet cell.
it is wet cell.
All
I
right,
think.
it is a wet cell.
all right. Yeah.
Let me open it just in
Ah,
it's could blow up. Okay, with that. I see. So to summarize, we learn about electrochemistry at least in at least the introduction of it. So we learn about cell and the electrodes, which basically the system and its a component. Basically, it is the component of electrochemistry process. There are two types of cell: voltaic cell, and the second one is electrolysis cell, which the galvanic cell means the from the from the chemical to electricity, while the electrolysis is from electricity to chemical, right? I kind of almost forgot there, but yeah, I guess that's true. So every cell has their own electrodes, which is cathode and anode, and it depends on the type of the cell. For example, like the voltaic cell is from the cathode is negative, right, Andra? And the anode is positive, right?
It depends on the
Yeah,
cell.
yeah. The
If it
the voltaic
is
cell.
if the cell is voltaic, then the cathode must be positive. However, when it is electrolysis cell, then the cathode is gonna be negative.
Yeah, yeah, that's true. That's true. Yeah. So that's what happens. There are many applications such as battery or electroplating from yeah, there are many ways to use electrochemistry in there. One of which is that. And from battery, we can learn that there are two types: dry and wet cell, which is depend on the type of battery we have. And battery has their own type too. Depending on first, we divide it by the fact that it could be rechargeable or not. The primary is cannot be rechargeable, it's not rechargeable, but secondary can. And secondly, we can see the type of battery depends on the material used for cathode and anode. Uh, uh, for example, like battery could be use zinc, carbon and zinc and manganese to be used as a cathode and anode, and they could be anything else like lithium ion or nickel or some cadmium or something like that. Yeah. So there's all of it. Does it cover? Does my summary cover everything, Andrea? Or do you want to add some more in there?
Yeah, I think that it already covers the entire discussion, man.
I see. All right. Anything else to add, Adil? Like, do you want to add something?
well, yeah, I think it is enough for India summary, and
Hmm.
maybe we can go to our Q&A session. All right.
Really?
Okay.
Okay.
Okay. Can we?
Uh, do we? I don't have
Well,
questions
I
so
have.
far. Oh, you have. So go on. Okay, please
Okay,
ask it.
Anda. So, do you have any experience in, you know, doing real life experiment with electrochemistry? At least in your school, not in when we were high school, of course.
Yes, yes. I think that I have I had an experience about it when it came to the laboratory experiments. You see, I have once experimented to do electroplating.
Electroplating.
Yes,
Electroplating.
yes.
With how does it work?
Yeah, it
What
works
is the
like,
goal?
for example,
I mean, yeah, okay, okay, go on.
uh, it works like, you see that, like this.
You going to show us with presentation?
Do
This
you do
shows.
you do you have your video doing doing that
Not video, but
experiment?
such illustrations,
Oh,
since
Okay.
illustration.
it's kind of complicated to explain. Like this, you see the electroplating.
Oh,
Yeah.
electroplating.
So I think that I do some electroplating for the coin here from the copper. Okay. So
Oh,
you see the I mean the coprum will cover the silver like this, and yeah, it is uh, protected by the copper. Yeah, something like you coat you do coating for your own
Yeah.
phone or coin. Okay, in in order to prevent rust in that iron, yeah, something like that.
Mm.
oh, I see. So you have this kind of experiment when you were um in laboratory IPB.
Yeah, when I did it, yeah, of course, I experienced to do some electroplating,
All
which is
right.
electrolysis scheme.
Hmm. I see. I see.
Yeah.
Is will you do you like do you in your daily life do you still kept doing this experiment? I mean, what I mean is, do you consistently involved in this kind of industry, like in this kind of
Idea.
idea of electrochemistry, or do
Well,
you?
I mean that I'm not really focused on this segment,
Oh, all
since
right.
in the third year of my college, it turns to be the hardest course I've
Oh,
ever
All
brought.
right.
Yes, so I think that's I feel like I feel kind of uncomfortable when it comes to electrochemistry. But for the basic, yes, I will explain it
I
for you.
see.
Yeah.
I see.
so there are many. There are still many things about
To learn.
electrochemistry that you know.
Chemistry, like calculation of the Faraday and the calculation of voltaic, and yeah, it's kind of quite complicated to calculate how the exact um, the both electrolysis and voltaic cell occurrence.
All right.
But no,
Understood.
maybe after I went through this, yeah, I will learn it for nutshell. I hope that I will get it through for, yeah, explain you guys
Okay, so
Mm.
you guys want to make batteries, right?
Just to research about it, small research,
more
yes.
research. Yeah.
So then it should relate to electrochemistry, right?
Yeah, that's
Definitely.
why. Yeah, the main topic of chemistry is supposed to be electrochemistry.
Mm. In the
All
battery.
right, all right. So, do you guys have any plan to carry out some better experiments or anything like that, or just literature study?
Well, at first we're going to have some literature study, like just read it, like how they design or something like that. Maybe in the future, we don't know. At least this is a good start, I guess, for us. Mm.
All right.
Yeah, it is such a good start. Good
Eh,
start to experience how the electrochemistry works in real life.
in battery, yeah, in real life.
I mean, when I was in electrical engineering in Universitas Indonesia, I was, met a lecturer where, we, I went to a certain club where
Mm-hmm.
we make some invention like electric bike, and
Mm-hmm.
then there was this lecturer. He came to us and said, hey, you know what, the most important stuff in electric vehicle is the battery. It is the hardest thing right now when it comes to electric vehicle. Yeah, it is the
Mm.
battery is the most important thing because you see, without battery, those vehicle won't be efficient somehow.
Yeah, that's true. We actually want to study about how can we improve the efficiency of a battery. Sorry, what I mean is the throughput of a battery, for example, like in right now, for example, in EV, the throughput of the battery for motorcycle is very low, right? I mean, you can only speed up until 60 kilometer per hour maximum, and then that's it. And there's that. We want to see if we capable of creating a EV that could be like motorcycle that could be at least almost like a gasoline, like a fuel, gasoline fuel, which can move. We can which can have a throughput more than like 120 kilometer, maybe at expense on uh, the 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 length, but we want to see if it is possible first rather
Alright,
than.
have you guys ever went to to go to use electric vehicle before, like bowling or
I have.
you have
Uh,
electric vehicle?
no, I don't have electrical, but I use it before. Like, you know, I think in Cikarang, at least in Cikarang, there are boom like there are trend to,
Yeah,
uh,
there is a booming branch of electric bike
yeah, electric
called
bike right
BIM.
now in
Have you
Cikarang.
ever heard about BIM, Aulia, Adil?
Beam?
Yeah,
What is beam?
the writing is like this. BM.
Yeah, beam.
Yeah,
I know
so
beam.
that is a small bike, right, Andra?
Yeah, it is kind of a
Yeah,
small EV bike
yeah. So,
which can be rented by the
mm,
customers to go around in the area.
Cikarang.
Yeah,
Mm.
Cikarang. And yeah, you should pay from your applications, which is cashless payments when you wanna utilize kind of that products.
Yeah, so basically we can rent bikes now, electric bikes in Cikarang. Like it's kind
Hey,
of
Renda,
so
do you know that the points of the electric bikes uh, keeps racing continuously? For example, like
really.
yeah, yesterday I didn't find any point for that for in an area, but now I could see the point is
Increasing.
yeah, is increasing and positioned in that area. So I
Yes.
mean, week by week, there are racing points there.
Hmm.
But I don't know
Oh,
if the bicycle will be stolen.
no, I mean it is
Uh,
a good business, I guess, to for them to create. But yeah, I mean for what we mean is lately electric vehicle is getting more normalized in at least in Cikarang, I guess. So we
yeah,
want to see what happens if there are any like things that we can improve in that industry, basically. Adil.
Oh, I
So
see.
there's that. We should end this
Yeah, I
podcast first, I
know.
guess.
but first I want
Uh,
to show about the electroplating that I already conducted in my lab. It is like this. All right.
yeah, okay.
So yeah, I electroplate the spoon like this with argentum. Yeah, and it becomes
Silver.
silver.
Okay.
Yes.
Got
And
it.
then
Got.
when I talk with Dahlan Iskan, which is former Ministry of BUMN and former leader of PLN,
Mhm.
he said that
What is this, Andra? Andra, become the the host.
yep,
You become the
You
host, Andra, or not? Or you're just participants?
I'm participant,
Oh,
but
participant.
I did talking with him.
you asked
Oh,
question too. Okay,
Yeah,
nice, nice.
I asked a question because it is the opportunity to ask him since it was two times I met him.
I see.
Yeah.
twice,
What?
So he said that
twice.
5 years later the
Mhm.
battery cost is 50% cheaper again.
Oh, so you asked about battery, and he said that battery in 5 years, the future of battery will be cheaper than ever.
Yeah, because
50%
now the battery is quite uh, now the battery is still quite expensive.
right now.
At the
Oh,
same time, the battery cost is now 50% cheaper from 3 years ago. So, but
oh,
although the battery cost is still expensive, but the trend uh is going down, man.
I see,
I
I
Yeah.
see.
see.
Okay, by
That
the
is
way,
interesting.
guys, it is already Ashar, so
Yeah, yeah. We're going to stop the
Randia,
pod.
please.
Okay. It's already Asha, so we're going to stop the podcast now. It was a nice experience. It was a great learning experience. And it is interesting that you talk to former ministry of in former ministry of what is it?
Uh, ne-
Sorry, former leader of PLN.
National State-owned enterprises
Yes,
or
enterprise.
BUMN. Yes.
PLN, right? So yeah. Okay. I think that's enough for our podcast today. Thank you, Andra, for your interesting
All right.
material, and Adil, thank you for hearing out and coming and interjecting with our discussion. So that's it, guys. We will see you guys in the next week. Thank you.
Inshallah.
Assalamualaikum.